Okay, hopefully this podcast will go a little bit quicker than the last one I did. Jared's telling me that I'm boring him, so Jared, this one is for you. So we're going to solve systems of equations by elimination. And you have seen this before. So we already did substitution, so where you solve one of the equations for one of the variables and substitute it back in. Now we're going to look at elimination. And our goal with elimination is to eliminate one of the variables. So when we look at this, we can either eliminate the x's or the y's. Well, looking at the y's, I have a negative 3y here. And so in order for that to disappear, if we add it, we want to have a positive 3y in the second equation. So in order to get a positive 3y here, we would have to multiply this equation by a positive 3. All right, when we do that, we get 9x plus 3y is equal to negative 15. And I'll go ahead and bring that top equation down below it so we don't get bothered by the one that we just multiplied. So a negative 7. So now we're going to add. The y's are going to cancel out. We get 11x is equal to negative 22. So x is equal to negative 2. Now we have to find the corresponding y value, so we're going to substitute back in. And we can pick either one. Let's just take the top one. So 2 times x, and we found x to be a negative 2, minus 3y is equal to negative 7. I am going to add the 4 over, and then divide by negative 3. So negative 2, negative 1 is where these two lines intersect. So let's just review what can happen then when you're looking for solutions of a system of two equations and two variables. Well, we could either have, like on that last one, two lines with different slopes, so they intersect in one point. So you're going to have an x and a y value. It could be that the two lines are parallel to each other. So if we're looking for a solution, we're looking for what they have in common. Well, they don't have anything in common, so it's empty set. And then the last scenario is if the two lines end up being the same line, so they coincide. So if they coincide then it's all the points on the line. Okay. All right, let's try this next one here. Solve this system. So looking at the x's or the y's, I would only have to multiply one of the equations. So this one is fairly simple, and I don't even have to change the sign. So let's say that we want to get rid of the x's. So the top equation then, we have to multiply by 2. Okay, so that'll give me 2x minus 4y is equal to 6. I go to combine, sure enough, the x's cancel out, and the y's, oh, they cancel out also. So that leaves me 0 over here. So I end up with 0 is equal to 6, because that is a false statement. Then that means there is no solution. So the scenario for this one then, if there's no solution, they have no points in common, is that those two lines are parallel. And if you look at the first one, x minus 2y is equal to 3. So remember, get the slope. We can go the opposite of a over b. So the slope of this line is negative 1 over negative 2. So it's 1/2. And then the slope of the second line, negative 2x plus 4y is equal to 1. Well, the slope of this is also negative a over b. So the opposite of a is positive 2 over b. So there we get a 1/2 also. So if they have the same slope, then they're either going to be parallel or the same line, but in this case they have different y-intercepts. So there is no solution. Okay. You could have systems like this where the numbers get kind of ugly. So in this case we have decimals. You could also have fractions, but you can still deal with those. If you don't want to look at those decimals, one thing you can do is just get rid of them. And so to get rid of them, well, in this case all of the numbers have 2 decimals to them, and so we are going to just multiply all of the equations, both equations, by 100. So that will give us 2x minus 5y is equal to 38, and 3x plus 4y is equal to 104. Okay, well, we can get rid of either the x's or the y's. Let's just work with the x's again. So I've got a 2x and a 3x, so I want to get a 6. So I'm going to multiply the top equation by 3. Okay, and when I do that, that's going to give us 6x minus 15y is equal to negative 114. The second equation then, we want to get a negative 6, so let's multiply by negative 2. So we get negative 6x minus 8y is equal to negative 208. So when we combine, we eliminate the x's. We have negative 23y is equal to a negative 322. And then when you divide, you get a nice little 14 there. So now we can substitute it in. You can go back to either one of your original 2 equations, or you can go back to one of these 2 also. Okay, so let's substitute the 14, oh, maybe just back in this one right here. So we need 3x plus 4 times our 14 4 times 14. 4 times 10 is 40. 4 times 4 is 16. 40 plus 16 is 56. And then when we subtract that, we get 48. So therefore x is 16. So our solution here is 1614. Okay, let's take a look at a story problem. So an airplane travels 2,000 miles, so that's the distance, and it's flying into a headwind, and it is taking then, in that trip, it's going to take 4 hours and 24 minutes. On the return flight then, with the same airspeed and wind speed, so on the last trip they were heading into the wind, so the wind was working against them. Now they're flying with the wind, so it's working for them, and it only takes them 4 hours then. So we need those 2 things, the plane's speed and the wind speed. So let's say that the plane's speed is x and the wind speed is going to be y. Okay, and we're also going to write down our formula for distance. Distance is equal to rate times time. So if we want to talk about the distance, well, our total distance is 2,000 miles. So we have that. And we also know that the trip, for that 2,000 miles, we've got to take our rate times our time. So we're going to use this formula, rate times time. They give us both of the times. So they give us the time for the first one, 4 hours and 24 minutes. So let's go ahead and convert that to a decimal. So we've got 4 hours plus 24ths of 60. So 24 divided by 60 is 0.4. So we get 4.4 hours flying into the headwind, and then 4 hours. Actually, let me grab my red. So here are our two times here that we're going to use. And what do we know about these? If we want to set up an equation, we got to find something that's equal, and their times are different. Their speeds, well, their airspeed and stuff is the same, but the rate ends up being different because one of them you're going with the wind and the other one is against the wind. But on both of them, what they have in common is that they're traveling 2,000 miles. So their distance is the same thing. But you have to remember that we've got to find two things. So to find two variables, you have to set up a system of two equations. So let's just take a look at the distance flying into the headwind. So our distance is equal to rate times time. Our distance is 2,000. Our rate, well, if we have the wind speed and the plane speed, and one of them, like we're going with the airspeed and we're flying into the wind, so the wind is working against us, so it's slowing us down. So it's our plane's speed minus our wind speed. That together will give us our rate, and our time was 4 hours, 4.4 hours. Okay, so that's our first equation. And then you think you can think of set up the next one. So think about what is different about this one and what's the same. So if you want to pause it, you can. I'm going to write it down now. So our distance is the same, but our rate is going to be the plane's speed plus the wind speed. So if the wind is behind us, then it's pushing us ahead at that rate also. And our time for that flight was only 4 hours. Okay. So now we have two equations in two variables. Okay. So we can think about how we want to solve this. You could distribute the two. So you can distribute the 4.4 up here on the first one and the 4 on the second one, and then you'd have the x's and the y's there, and then use elimination. If you see another way, maybe substitution. So think about how you could solve that using substitution. Okay, so I'm going to pause it for a second, or you can pause it for a second and solve that, and then turn it back on and see how you do. Okay, so to solve this, I might distribute on the top one. So I've got 4.4 x minus 4.4 y. Then on the bottom, 4x plus 4y. Well, one thing you can do, you know how you can multiply? Well, you can also divide. And it's like, I don't want these numbers to get too big. So let's take a look at that second. Whoops, I put an extra 0 there. I don't want that second equation to get too large. So I'm going to divide all the way across by 4. So then we get x plus y is equal to 500. Okay, on the top one, they are all divisible by 4. So if 2,000 is divisible by 4, well, 4.4 is divisible by 4. So then we would get 1.1x, whoops, minus 1.1y is equal to 500. And then you can even multiply by 10 to get rid of the decimal if you want. I think I will just go ahead. This is a minus 1.1, so let's just multiply this one times a positive 1.1. Okay, so I get 1.1x plus 1.1y, and then 500 times 1.1 is 550. Combine it, bring that first equation down. So I'm just rewriting this one. And then when I add, I get rid of the y's, so I eliminate the y's. 1.1 plus 1.1 is 2.2x is equal to 1050. And then 1050 divided by 2.2 is 477.27. Okay, so that is the x, so that represents the plane's speed up here. That's the x. Okay, so then we can take that and substitute it in to find what the wind speed is. So it doesn't matter which equation you choose. So I think I will take the equation then that I simplified. Let's see, I wish I had another color. This one, this new program only allows me these 3 colors. So let's bring this guy over here. So we want 477.27 plus y is equal to 500. So therefore y is 22.73 miles per hour. So that's the wind speed. So those are the 2 variables. Okay. Here's another application one, and this is one that you're going to see quite a bit in calculus if you're a junior and you're going to take calculus next year, because we have a more business-minded calculus than an engineering calculus, so we do a lot of business application. And when you have supply and demand, and I have just the 2 equations given here, we have a demand equation and a supply equation for some particular item that we want to sell. And what you want to look for, since we're looking for the equilibrium point, is where the demand is equal to the supply. Okay, so here are our 2 equations. So just the way the 2 equations are set up, and the x represents the number of units that you're going to sell, and the p represents the price for that unit, and we want to find both of those. So if we're looking for an equilibrium point, we need both of those values. I need to know at what price and how many items would you sell. Okay, well in this case, I think I would use substitution, even though this one is on elimination, but this system of equation begs for elimination or a substitution, because these 2 things are already, both of these equations are already equal to p, so that means they have to equal each other. So then we go 150 minus 0.00001x is equal to 60 plus. Now I have an equation in only one variable. So I can solve that equation fairly simply. I'm going to add the 0.0000x, 1x to the other side. So I get 0.00003x. And then we're going to subtract the 60. So we would get 90. And now you just have to divide by this decimal here. We're dividing both sides by this decimal. And so for x then, you would get 3 million. So you could sell 3 million of these units, whatever they happen to be. And now we have to figure out, well, if we sell that many of them, what price can we get for that? So we have to substitute it back into either one of those equations to figure out what the price would be. So if you pick the first equation and you plug it in, you'd have 150 minus 0.0001 times x, which is 3 million. And then you can solve that to get a price of $120. So the solution is this many units at this price. Okay, so there's another example of this time, setting up an equation, setting up a system of equations in order to solve them. Now, I would like you guys to try these particular problems. I won't even make you do any word problems. We will wait and do those in class. Okay, so you can write those down, work on those, see if you have any questions. Hopefully this will come easy to you. You remember that. And I'll see you in class.